Okay. So if we know a derivative is positive, it tells us the function that you were taking the derivative of is increasing. So if f double prime is positive, what does that tell us about f prime? Increasing. You don't necessarily know about concavity there, because you would need to know the third derivative to know about the concavity of the first derivative. Put your computer up and quit messing with delta math right now. Okay. All right. Negative would tell us that the first derivative is decreasing. All right. So, and if we know that the second derivative is positive, what does that tell us about the original function? Concave up. And then we'll have concave down over here. So what we're going to see is a lot of times we see problems with tables or graphs, and it may only give us the first derivative, or it may only give us the original function, but it might ask us questions about the first or second derivative. So we've got to answer from whatever we're looking at. So like on the warm-up, we had to answer that justifying from the first derivative, because the first derivative was all we could see, right? So while I wanted to talk about concavity, and I wanted to talk about second derivative, I didn't have the second derivative. But if the second derivative is positive, then f prime will be increasing. So f prime being increasing is the same as knowing the second derivative is positive. Both of those indicate that our function should be concave up. Same thing if we're negative here. Yes? It could. There would not be a conclusion for f of x, though. Yeah, so like, yeah. Like if we were looking at a third derivative, yeah, so like we were looking at a third derivative here, we wouldn't know anything here, we wouldn't know anything here, but we could, like, if we know the third derivative is positive, we could say that this is increasing and this is concave. Yes, but it's just those three. Yeah, yeah. Typically, they are only going to ask you about the function, the first derivative, or the second. I have not seen any questions about the third derivative where they're asking you for increasing or decreasing. They may occasionally ask you for third derivative just to find it, but not to answer questions about it. All right. Okay. Okay. So I want to do one of these. I used to do a lot more of this, but I want to do one of these where we are going to try to figure out any and everything we know about this graph and sketch a graph. So let's start with some things that we know from pre-cal. If I want to find X-Intercepts, at X-Intercepts, y equals 0. So we would set this equal to 0. And really, that denominator just sort of cancels off. It's not going to make it 0. So you would end up really just with x squared minus 9 equals 0. So x squared equals 9. So x would equal plus or minus 3. So we got X-Intercepts at x equals 3, x equals negative 3. So we're not finding like critical points here, so we don't want to know where the bottom equals 0 is actually going to give us something different here. It's going to give us those vertical asymptotes for this one, because we're not looking at a derivative. This is just the original function. If I want to know the y-intercept, what do I do? Not y, x equal to 0. So it would be y equals 2 times 0 squared minus 9, over 0 squared minus 4. So I'd get 2 times negative 9 over negative 4. So negative 18. Sometimes it should be positive 9.5. So y-intercept. Usually if you see a FRQ where they ask you to graph what they have done is like part A asks you to find maybe an X-intercept. Part B asks you to find where it's increasing or decreasing. Part C might ask you to find concavity. And then part D will ask you to sketch a graph of like a certain section. So it'll kind of have you do some of this work first and then ask you to sketch a graph for that.
So there's a possibility because they can do like anything, or does everyone?
No, everybody gets the same one. Everybody in the whole country gets the same one. They will release, U.S. version of the test. There are like alternate versions for whenever they are like, so there's an international version that's not given in the U.S. There is like a couple extras ones that they use for the late testing. Like if you for some reason are sick and can't take it on May 9th, then there would be like a makeup date later. So there's a few other versions of the test, but assuming that you guys get the regular version, which I have never had a class not get it. So assuming you get the regular version, all 6 of the FRQs are the same for everybody in the whole state. 48 hours after the test is over, they will release those questions. So I constantly like check to see so I can see what the questions were, and then we'll like actually work them out in class to see how you did. So, all right. So X and Y intercepts. Let's do vertical asymptotes. Vertical asymptotes give or whenever our denominator equals 0. So x squared minus 4 equals 0. So x squared equals 4. So x equals plus or minus 2. So we've got vertical asymptote at x equals 2 and x equals negative 2. Well, we're only going to do one of these, but yes, these take up a lot of room. I mean, if you need to, like, I probably would not put VA on the actual FRQ. Mm-hmm. What?
Is there a way to tell like how the graph ended out?
Yeah, I'm pretty sure that's not going to be accepted because I'm not sure what. I'd probably just write it out.
So for increasing, decreasing, I and C and D, E, C, would that be like universal enough?
I mean, I think so. But to be extra careful, I would probably write it out. Mostly because one of the comments that one of the people made was that because I and C dot would probably be accepted for increasing. But if your handwriting is not great and they can't make it, like if you're writing out the whole word increasing and your handwriting is so bad that they still can't tell it's increasing, Noah Stewart, then
increasing.
Talking about your handwriting. So like you are less likely to lose points on that. So I mean, use your discretion on it. I am going to start taking off just a little bit if you put plus and minus signs instead of positive and negative, just because I'm afraid it would be an issue. But other abbreviations, I'm going to use my discretion on. If it's pretty clear to me, I will take it. But and certainly if it's like something that you may have sort of made up, it won't be any good. Mm-hmm.
What if you take off the answer a mix of English and Spanish?
Yeah, what if I answer everything in Spanish just as like?
That is an excellent question. I mean, just to see what would happen,
Yeah.
I think. I wonder how that works. Because, like, whenever they give,
They might have interpreters.
they give the test all over the world.
Like if you
I
put
know.
X-
So, like, there's kids in Mexico taking the AP exam.
Yeah, like X
And,
is half, something,
Yeah.
blah, blah.
but my guess is whatever language you take the test in, you have to respond in that language. That'd be my guess. So, like, unless you are given the Spanish version of the test, I think you would, and I don't know if that's something that could happen, like, here, or if you'd have to be somewhere where they administer Spanish to everybody. But I would assume they have a Spanish version. I would not think that the kids in Mexico are taking
They're probably just
A-
There's no way to
what?
There's no way to
I'm pretty sure there's kids in Mexico taking the AP exam. Maybe not as many as here, but
Why do you think so many people move to Mexico to get like degrees?
well, I mean, I do believe that our education system is probably a little better than theirs. I know that when I was in Mexico, the public school teachers were in the town square burning buses. They were. There was like a huge, like all summer long. Like I was there for 6 weeks, and the whole 6 weeks I was there, all of the public school teachers were on strike. It was still during their school year because it was June. It was still their school year, and they were all on strike, and they were all like in the like town center, like there, and like where normally it was like really pretty nice part of town. They just had like tents everywhere. They were living there and had like signs and all kinds of stuff. And I mean, it wasn't like it. I walked through there several times. It wasn't like, yeah, they weren't like aggressive or, except one day the director of our program called me and said, "Don't go to school today. Turn on the TV." And so I turned on the TV, and like the police were trying to like run them out, and they were like using rubber bullets and fire hoses and stuff. And then like the teachers were like burning buses. Like I rode by the next day. The next day, I rode by like the charred remains of a bus. I saw it on TV burning, and like next day, whenever I went to school, it was there. Whenever I was there for study abroad, I went for like a 5-week program down there. It was Spanish. No, it was because I double majored in math and Spanish. So I was taking Spanish classes. Yeah. Yeah. So, yeah, I can probably speak Spanish about as good as like a normal Spanish 3-year-old or so.
That was so weird, Alfredo.
Okay.
I forgot your shoe was there. I forgot.
Okay. All right, let's continue on. But I'm sure there are lots of good educated people in Mexico. Although overall, it's not quite as. Overall, the system could use some improvement. The lady that I lived with said that she did not. Her kid went to private school, and she said because she did not feel like their education system was as good. There. Okay. All right. Vertical asymptotes. All right. Now let's do horizontal asymptote. How do we find horizontal asymptote? We would do limit as x approaches infinity of f of x, which is Bobo-Botno. If we distribute that 2 right there, we're going to have 2x squared over x squared. We'll get 2. Because here, exponents are the same, so we would divide their coefficients. Yeah, if they didn't have 2, it'd be 1. Yeah. The best thing to do is just bot no, which is exponents are the same. So your exponents are the same top and bottom. So you're just going to divide the coefficients of the highest exponent. So like you'll have a 2x squared when you distribute that 2, and you'll have an x squared on the bottom. So just do 2 divided by 1. You totally ignore the other parts. The other way we did it is we divide everything by x squared and then sort of plug in infinity, which is still valid. You can do it that way also. For this one, negative infinity would be the same. So let's take our first derivative so we can know about increasing or decreasing. So for that one, we would have x squared minus 4.
Quotient rule.
Yep. I actually probably would do this. I'd do 2x squared minus 18 over x squared minus 4. It'll just make it a little easier to do this. So we'll have 2x squared minus 18 will give us 4x minus 2x squared minus 18 times 2x all over x minus 4 squared. Just quotient rule. And so if we distribute and clean this up a little bit, we'll get 4x to the third minus 16x. And then we'll get 4x to the third. Yes, that's, yes. All right, shh, guys, quiet. We've got to get through this, and the distractions are making it difficult for everybody to follow. Okay, distribute that negative, and the 4x to the third and the negative 4x to the third will cancel. We got negative 16x and positive 36x, so we'll get just 20. Are we okay here? Negative 16, and that's going to be a positive 36 when you distribute that negative. Okay? So, my critical points here, I'm going to have 20x equals 0, so that's just going to be x equals 0. And then we'll have x squared minus 4 squared equals 0, but I'm going to pretend like I already took the square root there. X squared equals 4. X equals plus or minus 2. Yeah. It's because you got vertical asymptotes there, so a lot of different stuff is going to occur there. So, if I eventually, yes. This is a super long problem. We're only going to do one like this, but it will. You may get one like this, but it will be like an FRQ. They probably won't ask you every single one of these things, but they'll probably pick like 3 things. They might ask you about vertical asymptotes and concavity and maximum minimums or something like that, and then ask you to sketch a graph. So, when I give it to you, it'll be like the FRQ version of it. Right, it'll specifically ask you for each piece and then ask you to sketch a graph rather than just general like this. I should probably just rewrite this question where it does that. Alright, so x squared minus 4 squared, what do we know about it? It's always positive. Okay, and then 20x, it's going to be positive if x is positive and negative if x is negative, right? So we'll have a negative here, negative, positive, positive. So negative, negative, positive, positive.
So there is a relative limit of x.
Okay. All right. So, concavity is our last thing. I know, there's not enough room there. I need to redo these notes.
Chain rule inside of Quotient
I feel
Rule.
like I'm writing like Danny now.
It's just a complicated mess.
All right, you've got the 2x squared minus 4 and this x squared minus 4. And we're going to factor one of those out so that we don't have to square that out. You could square it out, but then you're going to have to factor again. So we'll get 20 times x squared minus 4 minus, this will be gone, so it'll be 40, 80. So we'll distribute here, and we will get 20 x squared minus 80 x squared over x squared minus 4 to the 4th power. So you can cancel one of the x squared minus 4s with one of these 4 of them down here and make that 3. You're going to have negative 80 minus 60 x squared over x squared minus 4 to the 3rd power. We have, since we already made a sign line for that, you don't necessarily have to. Why is it disappearing whenever, right? Okay, I don't know what's in there. So we're going to set top and bottom of this equal to 0 because we need to know concavity. So we get negative 80 equals 60 x squared divided by 60. I'm not sure if that's supposed to happen or not. Have I messed up my signs somewhere?
It's too much for me to process.
It's so cursed. Just merely omit the name.
Stop saying negative like that.
Alright. I was thinking we should get, let's see if I've got this.
Yeah, I know.
No, we're okay. We're okay. It's okay. So you should not get anything here. Here you're going to get x squared minus 4 equals 0. So x squared equals 4. X equals, again, plus or minus 2. Alright, so if we plug into our derivative, this is for This is for second derivative, which is going to give us concavity. So if we plug in here,
Wait, can we just assume concavity based on the max?
Yeah, but it's assume it based on F.
not necessarily,
Why?
because it could change.
Like, if you have an asymptote at a minimum, of course it's gonna go down.
You can't. You would
Obviously.
need to check to prove that that has to be the only way. I'm just going to tell you for sake of time here, you should get negative, positive, negative here if you plug those back in. So, we are finally to sketching a graph.
Where's the graph gonna go?
I need to redo these notes so this problem's more structured. All right, so some things we know. We know we've got vertical asymptotes at 2 and at negative 2. All right, so we're going to have X-intercepts at 3 and negative 3. We're going to have a Y-intercept at 9/2. So 4.5. Let me make my graph just a little bit taller here because I did not go up quite high enough. Okay, so between from negative infinity to 0, my graph should be decreasing because my first derivative is positive. I should have also drawn in my horizontal asymptote, which is just really the x-axis. And so I know if the graph is decreasing right here and then switches to increasing, then I'm also have to have a U shape here, plus second derivative is positive, which tells me I should be concave up, which falls in line with that, right? And these would be asymptotes here for this middle part. On this side, I need to be decreasing, and second derivative is negative, which tells me concave down, right? So decreasing and concave down would look like this. Hold on. I think I graphed my horizontal. Oh, I'm sorry. My horizontal is, let me back up. My horizontal asymptote was at 2. It was not at 1. 0. I don't know why I was thinking that. And then over here, we're concave down, but we're increasing on this section. So we would graph this here. Yes. Yep. To show that you, a lot of times they will restrict it to a little smaller area, so it might just be like from 0 to 2. If they ask you to graph this, or like, I've got some FRQ problems we'll do for practice eventually, but they'll grade it based on, like, typically they'll ask you, like, parts A, B, and C have asked you for information. Like, they might have asked you for concavity, they might ask you for increasing, decreasing, they might have asked you for points of inflection. So then when you graph it, what you graph has to match your answers that you had for that. Okay. All right, now let's look at what the multiple choice questions are going to look like, okay? When you see I didn't put a calculator picture here, but when you see decimals like this, know it's calculator active. So let's get our calculators. Please follow along because some of you guys do not know how to use your calculator very well. Okay, so let's talk about this a little bit before we graph it so that we can be smart about answering this question. Okay, they give you the first derivative and the second derivative of h. And then they ask you on what intervals is the graph of h both increasing and concave down. So it is asking us about h. It is not asking us about h prime or h double prime. So when you graph one of these, you're not looking at the graph it's asking you about, right? You're looking at the derivative or possibly second derivative. So if the graph of h is increasing, what does that tell us about the first derivative?
Positive.
First derivative is positive. Okay? Concave down, what's that tell us? What is it? Okay, so a lot of times I typically think about h double prime with concavity. You're exactly right, though, Laura. So I'm just trying to walk it through. So I think about this, it's less than 0. But that means that h prime of x should be decreasing. So, for this problem, h double prime of x, you can use it if you want, but we can get this just by looking at h prime. We're looking for whenever it's greater than 0, which means above x-axis, right? And also where it's decreasing. So you don't have to graph h double prime. You can, but it is going to make it more difficult if you do. Concave down is going to be negative, which means that it's decreasing. H is increasing, which tells us the derivative is going to be positive. But concave down tells us that the derivative is decreasing. Okay, so three natural log of 2 plus cosine 2x minus x. Oh, let me delete out that. Okay. Alright, I think I've got everything in correctly. I'm going to hit graph. We're only looking from -2 to 2, which thankfully I already had in there because so we are looking for where this graph, I'm going to copy it real quick. I think so. Hit enter and see if it'll let you. Ooh, that's not going to work. Well, it doesn't work. So we're looking for where h prime is positive, meaning above the x-axis, but also decreasing. So that happens right here from -2 down to this point right here. And then again, from whatever this is, down to this point right here. So we can eliminate C because it's only got one section, and D. Because they only have one place where this happens. And then we really just, so which point is the only one we really need to find? we really just need to find this lowest point right here because everything's the same for the first part, right? We just need to find this point right here. When you need to find something on this graph, you're going to hit F5. And we need to know a minimum point here because we need to know when it quit. Actually, no, take that back. We need to know 0, don't we? Because we need to know when it hits that x-axis because past there, it's no longer positive. So we're going to do the 0. Even though, do we even really have to look for that? It's got to be A. Because it is going to, I mean, it probably has to be A, because I bet 1.656 is this one over here. But to be safe, we could check it. I feel better whenever I actually see the same number show up. Or did you change your window to where your x's are from -2 to 2?
Mine completely drops it off just before one.
So we get 1.085, which is A here. Okay, let's look at this one real quick. All right, so F is continuous from 0 to 16. It's twice differentiable. It's set at 5. Where the derivatives are undefined, its information is given above. Let's see. Did I cut this? Okay. At what point does the graph of F have a point of inflection?
That's when the
second derivative switches sign. So here we're positive to negative. And then from negative back to positive right here. So we would have 5 and 8. There would be our answers. Point of inflection. What does it mean happens at point of inflection? What switches from positive to negative? F double prime, which means that you have a change in concavity. So the second derivative is where we look for concavity. We look to see if it changes signs there. Yeah. Okay. All right. The graph F prime is shown above. Which of the following could be the graph of F?
Well, that there's the...
So this is the derivative.
I'm going to guess C.
Okay. What about A? Do we think it's A? No. Although A would be F double prime. Like if they had asked you to find the derivative of this one, instead it would be that. But it's not this. All right. So what should we have right here? A minimum. Because our derivative goes from negative below the x-axis to positive. So we should have a minimum. So C and D both look like they might have minimums there. Right? Right here, we should have a maximum. So B is out. So C looks like the right one. Because here you don't have a maximum. If you're unsure, though, think about what's happening here. Our graph is increasing all the way up to this point, right? If our graph is increasing, what's that tell us? Or our graph of our derivative is increasing. What's that tell us about concavity? concave up, right? So if this graph is increasing, will be concave up, and this looks like it's concave up to about right here. This one is concave up. It looks like it probably switches much closer here. Then we should be concave down for the rest of the time because our derivative is decreasing. This one's concave down everywhere. This one's concave down, but then it switches back to concave up. So D is out, and C is your best answer.
I get it. I get it.
Okay?
Pictures make sense.
Okay? All right. The function f is differentiable and increasing on the interval from 0 to 6. And the graph of f has exactly 2 points of inflection on this interval. Which of the following could be the graph of f prime, the derivative of f? Okay? So, what happens? All right, so we're talking about points of inflection, right? So, points of inflection is concavity, which is second derivative. Okay? So, our second derivative has to go from positive to negative twice, or negative to positive, right? But we only have the graph of f prime. Okay? So, if the second derivative is positive, what does our derivative look like? Increasing and decreasing. So, for a point of inflection, we should have our graph switch from increasing to decreasing twice if we've got 2 of them. So our graph of our derivative, this one increases everywhere. It is not right. Here we increase up to this point, we decrease to here, and then we increase again. So we would have 2 points of inflection here. For B, we only switch 1 time. It's not it. For D, we switch here, here, here. We got 3 for D, so C is the answer. It's okay that you have a cusp in the graph there. It doesn't rule it out. That is for maximum minimums. Maximum minimums. It's kind of difficult to keep those things straight. That's what you have to practice with. All right. Okay, last one here, I think. Yep. Okay, so this is my second derivative. We want to know which of the following could be the graph of f. So, now this is second derivative, it's not first derivative. So, when I see 1 and 4 here, what do I have at 1 and 4?
Relative to inflection. Oh, yeah.
Points of inflection, not maximums or minimums because we're looking at second derivative. So, A is not it because that's where you end up with maximums and minimums. So, it's not it. C at 1 and 4, it kind of looks like you're switching concavity there. I'm going to keep that in the red. B, 1 and 4, those are maximums and minimums. That's not it. 1 and 4 right here. Here you do change concavity at 1 and 4, but you also got a lot of other crazy stuff in between, right? So it's not going to be that one. Here, you're concave down, then concave up because this is positive, and then concave down again, which is here. So C would be your answer. So let me show you. Your delta math is going to have several different types of things. All right, so let's look at this, okay? All right. Okay, so you, quiet please. Okay. The biggest thing for this is you need to know what graph you're looking at. Because some of these are going to give you F, some will give you F prime, there may be even some that give you double prime. So this is F prime. So it says on the interval, it can be seen that f prime on the interval from -1 to 2, so we're talking about -1 to 2 right here, is from -1 to 2, we're negative and increasing and concave up. So this is asking you about f prime. Based on these observations, you would conclude that on the interval from -1 to 2, f would be from -1 to 2. If I have a negative derivative, what does that tell me? Decreasing. If you want to use the bathroom pass. Okay, y'all don't let me forget. She's got to have. Was she upset, crying? Okay, I'll talk to her in a second. All right, so so here we're talking about negative. If our derivative is negative, what's that tell us? If our first derivative is negative, then our function is decreasing. And I know that this first derivative is increasing. What does that tell me? Concave up. So I need to say that this is decreasing and concave up. Because f prime is negative and increasing. -1, which is right here, to 2. And then f double prime would be positive, because f prime is increasing. So you got to pay, hopefully I'm right, you got to pay close attention. Now, not all the problems are like that. Some of them are going to ask you different. Like this one's like positive, negative. This one's a little bit more simple.
Wait, so if the f prime is 0, then what happens to
Double prime, think about whether the graph is increasing or decreasing. So like at -6 here.
Yeah, but it's
So here you get -1 for this one. So it's less than 0. So this is f. F prime, because you are decreasing, it would be negative. And then f double prime, because you're concave up, would be...
because f prime of 3 is 0 at that point.
All right. Okay. That's fine. All right. So are you second derivative? Think concavity. Are you concave up or down? Down. So second derivative is going to be negative.
So this one was similar to the one that you just said. I got the first part right. I just read it from -3 to 0.
Yes.
And then -3.
Alright, increasing concave down is correct. And then just say because you're positive and decreasing.
Positive and
Yeah.
Oh, because you're,
Yeah.
okay, now this one. Okay. And then this would be -3, 0 for f double prime. It would be only going one way. It would be only negative. And increasing.
Yes, that's right. That should be right.
So basically, f of -6, that's just like finding the point.
Right.
And then f prime of 6 is basically the slope. And then
Yes.
f double prime is if it's concave up across.
Yes.
So how can could you straight up just look at that and tell if f double prime is positive or negative? Or do you have
Yes, because the derivative, because right here you're concave up. Since you're concave up,
Yeah.
then you know that second derivative has to be positive.